Hello everybody, so today I am very excited about this video. I think it's going to be the funnest and most exciting part of all the evaluation videos I did for this circuit. Again, we'll be using the PPK2 to evaluate currents going through this circuit, but we did like sort of a test, I guess. I added a few more test points that I should have added in before. One was right here. So to see the current going through the photoresistor, and one was coming out of this collector here, right here, and then another coming out of this collector here. So yeah, I hope that you are as excited about it as I am, and please enjoy the video. Okay, so today I'm just showing you I wrote in uh, 3 different new test points just to sort of explore this circuit a little bit more. So the first one is the current that goes through the photoresistor, and I just put my prediction as dark would be much less than the light. Like so when it's in the dark, the current going through the photoresistor will be very small compared to the current going through it in the light. So the next one is the current coming out of the collector of Q2, and I estimated that it would be 37 microamps in the light and 0 in the dark, because effectively Q3 and when Q3 and Q4 get turned off because of the light being gone, then there would be no current from that collector. Now over here for Q1, in the dark I said 0 because again it's turned off because there's no current going through or coming out of its base. In the light I put a question mark because I'm not sure how much will be going there. I think in the real bright light it will be 0, but in the not so bright light it may be iffy. Same with, I guess, in here coming out of the base of Q1 and Q2, it might be a little bit less than 37 microamps. Anyways, let's go to the bench. So we got everything ready here. Let's just connect one of our grounds again. Might as well go with the ground on this LED again. Let's start with the current through the photoresistor. So this would be V in there. Then V out. Now we shall just start. So you can see it is varying a fair bit. Let's just verify that we are actually. Yeah, so you see I cover with my hand, it comes up. We can change it like that. So I'm gonna say in the light about 91 microamps. I'm just writing it down in my notebook here, not in the spreadsheet. Now let's turn the light off. Let's really cover it here. Yeah, so I'm just blocking the light from the open or like the window I have in the garage here. And as you can see, we can get it down to like 5 microamps. 6 microamps about. In dark, 6 microamps, which, because we are wanting to drive that transistor up to putting through about 40 microamps, that means we would want the minimum, but we have two, so we could actually be reaching the minimum. We would be right on the precipice, I think. So I just wanted to give some clarification of what I was talking about. So here I said, like, okay, we have 90 microamps going through here in the light. So, but then in the dark we had like 5 microamps or whatever. But the main driver here actually is, so we would have 5 microamps that go in here. That means that we have, so here we would have 5 times 33. This would actually, well, we'll go here. So that would be 165 divided by 1000, because we're dealing with microamps there. So that would only be 0.165 volts. So that's all we'd be seeing here. That means that there's no way that any current can flow through this transistor, because the base just doesn't have enough voltage. Like it's less than a diode drop. So that means that there just nothing would happen, which is why this current turns to 0. Anyways, let's move on to the next. Okay, so we'll unplug these. Let's go to this one here. So I'll say Q2 base, we'll call it. And in light, we're having probably right around 30 microamps. Now, let's turn off the lights. And we're going to have right at 0. Actually, looks like it's bouncing. So yeah, I can have it almost off, but not quite. We're in a low light situation right here, but not right dark. Mostly because there's so much light coming through the window, eh? But then if we go here, turn it right off. Just say in low light. And microamps or less. What is probably the minimum or the maximum light or amperage it can have while the LED's still on? Yeah, I would say it's at 10 microamps. Or less. Otherwise, everything is off. Okay. Okay. So now Q1 collector in light. It looks like 85 nanoamps. Now let's turn these lights on. Right now, in the sort of low light condition, low light, we're at probably 2.5 microamps. You see what happens when I go to start to cover it? It really catapults itself up because it's starting to compensate, but then eventually it just gets turned off. And you see there's 0. Hi. Thank you for watching the video. It's all done now. I hope you liked hearing about how we analyzed all of this circuit with the PPK2. Now I did want to just say, like the last part of the video you saw here, we were seeing the current through Q1's collector right here, and one thing I wanted to like sort of point out on it, but I don't know if it got through well, is how it spiked up when you went to go turn this off. So I think what was happening there is that this started to turn off, so the less current was going through here, and then it called for more, and eventually this was like, oh, I need to send more current through, but eventually this just stopped bringing in any current at all, which turned Q1 off. It was an interesting little thing. That was those big blips on the PPK2 screen. But anyways, I just wanted to point that out. Thank you for watching, and I hope you check out my future videos.